In November 2022, the human population crossed 8 billion. For many, that number represents a looming disaster, a world running out of water, food, and the space to sustain itself. Much of this fear traces back to Thomas Malthus. In 1798, he proposed that human population grows exponentially, multiplying like an unstoppable bomb that eventually starves its own host. This chart compares that original explosion theory against actual data points from the United Nations. While the total number climbed rapidly since the Industrial Revolution, the growth rate is slowing. Peak projections are revised downward. We once feared 15 billion. Today, the UN expects a plateau at 10.3 billion in the 2080s before a decline. Demographic models often miss these shifts because they treat population growth as a straight line, moving toward a single point. Ancient Indian traditions like the Surya Siddhanta and Sankhya philosophy proposed a different geometry. They modeled the human population as a cycle, spinning through predictable phases rather than launching into infinity. Apocalyptic predictions fail when they assume history is a one-way path. Viewing time as a circle changes the interpretation of the data entirely. Sanatana mathematics describes population growth moving across a curved, horn-like space. It follows a logarithmic spiral, wrapping more tightly as the system reaches its limits. The speed of this spiral is determined by factorials: 10 factorial, 11, 12, and finally 13. 10 factorial, roughly 3.6 million, correlates with global population estimates at the dawn of agriculture 10,000 years ago. 11 factorial reaches 40 million. That matches the estimated world population during the height of the Indus Valley Civilization around 2200 BC. 12 factorial brings the count to 480 million, the approximate number of people alive during the global shifts of the 16th century. To understand the next threshold, Sankhya philosophy looks at the human instrument. It identifies 13 distinct functions: 5 senses, 5 organs of action, and 3 internal states of mind, ego, and intellect. The theory suggests that 13 factorial, or 6.22 billion, represents the maximum possible complexity of these combined human expressions. If 6.22 billion is the species' natural threshold, we have seemingly shattered it. We are currently over 2 billion people beyond that point. In this mathematical model, 6.22 billion acts as a line of equilibrium. A population can overshoot that line, but doing so triggers a natural corrective force that pulls the species back towards the center. Historically, these corrections have taken the form of the Black Death, the Spanish flu, or the massive casualty rates of global wars. Each event dramatically reduced the human count after periods of rapid expansion. Through this ancient lens, plagues and wars act as self-regulating mechanisms, keeping the species within the constraints of the factorial limit. Today, we aren't seeing a single world war or a plague capable of erasing billions of lives. So how is this corrective force operating in the modern world? The correction has become silent. It is happening through the unprecedented global collapse of fertility rates. A population needs a fertility rate of 2.1 just to stay stable. Japan is at 1.26. South Korea has fallen to 0.72. History contains no record of a society recovering after dropping below these levels. Even in India, often cited for its growth, fertility has dropped to 1.9. In many southern states, the numbers are already as low as those in Japan. Modern policy is built on the idea that more people equals more wealth. But while Nigeria's population grows at 7%, Japan remains one of the world's largest economies despite its shrinking numbers. The logic of wealth is independent of the logic of population. A shrinking global population follows the same cyclical logic as the seasons. It represents a natural resetting of the system. Embracing the ancient mathematical cycle allows us to see this shift for what it is. Humanity is letting go of the myth of infinite growth and returning to equilibrium.